Today we're going to learn about one more method for solving a linear system. So if you haven't done this sheet all by yourself, then give it a try. If you get stuck, you can come back here to check. All right, so when we are adding and subtracting things normally, if you do something 5 plus 7, we just add 5 and 7, it gives us 12. If we're subtracting, we got 15 minus 6, gives us 9. You've done this before. So when we're adding and subtracting the same way, when it comes to incomplete expressions. So what you need to remember is if I'm subtracting each element from the top from each element at the bottom. So that'll give me 10x minus 5x gives me 5x. Negative 20 minus 12 gives me negative 32. 80 minus 25 will give me 55. There's my answer. Now, if I take this entire thing and I add it instead, that gives me 10 plus 5 will give me 15x. Negative 20 plus 12 will give me negative 8x. And 80 plus 25 will give me 105. So things you should notice before doing this is that all of my x's are lined up, my y's are lined up, and my numbers without a variable are lined up. If I have something like this, oh, what a mess. So we've got my x on top of my y, my numbers on top of the x, and I've got a random 20 over here. That won't work, okay? So the variables don't line up. I can't do anything with this. This is gonna give me chaos, okay? So make sure that you are rearranging your equations to look like this before you try to add or subtract them. So now hopefully you've gone through and you've taken a look. I'm not going to go through each of these exactly because that's time consuming. So I'm just going to put it all on the screen for you so you can check your answers. So the moral of the story here is that this piece here, if I subtract, I end up with 0y, right? So what have I done? I have gotten rid of a variable. So subtracting is more useful. Here, I got rid of a variable, so subtracting is more useful. Here, I didn't get rid of anything. I added, I subtracted, I got the same thing. I still have two variables. This is not helpful because as we said last week, in order to solve an equation, we need only one variable left. So what's really great about this is I have one variable left. I could solve that. I have one variable left. I could solve that. Here, if I add them together, I end up with a 0y, so adding is best. Now I want you to notice, if I'm subtracting, the symbols in front of the one I'm looking to get rid of or eliminate are the same. So if their symbols are the same, I'm subtracting. If these were both negative, I would also subtract because a negative minus a negative is going to get you back to 0, right? If the numbers are, if the symbols in front of your variable are different, so if I have a positive and a negative, then I want to add them together to get back to 0, right? So just keep that in mind. So here, if I add them, I get rid of this variable. If I subtract them, I get rid of that variable. So I can add or subtract in this case. And here, this one, if I subtract them, so as I said, if there's two negatives, I subtract. So if the symbols are the same, you want to subtract, the symbols are different, you want to add them to get back to 0. Okay, so what is marvelous about this method? Well, it causes us to eliminate one of the variables because you can only solve an equation with one variable. Okay, so this is an important skill to have when we're moving on to something called elimination. So elimination is another way of solving an equation, except we don't have to do any of the substitution that we did in the last lesson. So for here, we have, here's our equation. I want to eliminate one of my variables. So in this case, these two are the same. I'm going to subtract them. 4 minus 4 gives me 0. 5 minus 7 gives me negative 2. And 20 minus 32 gives me negative 12. Okay, divide by the coefficient in front of y. Gives me positive 6. Now, just like I did with substitution, what I like to do with elimination is box in my first answer, because if you don't, like I'm using multiple colors and boxes and lines, you're going to be using all pencil. This just looks like chaos at some point, especially if you don't have super neat handwriting. And I know when I was in high school, I absolutely did not have super neat handwriting. This is something I developed end of university, that you can read my writing really nice. Until that time, I absolutely did not have that. So boxing in my answer is a good way that I can find it later. So then I'm going to pick whichever equation I like best, because you can use either one. I happen to like the 5y, so that's the one I used. I sub in the 6 here, do my multiplication. 5 times 6 is 30. Subtract 30 from both sides to get the x all by itself. Divide by the coefficient in front of y, and naturally leave it as an improper fraction. You want to get used to this. So you got negative 5 over 2. Now, here's the most important part. Make sure that your x comes first and your y comes second. I see this is a common mistake, that people just flip it and get it backwards, especially if you solve for y first. People will give me 6 and negative 5 over 2. Be careful. Make sure you're giving me your x first and your y second. All right? Same thing for this. So this time we're going to add. You could have subtracted and got rid of the x. I chose to add so that you can see that this is a method for adding and this is a method for subtracting, but it's whichever makes you more comfortable. You could subtract this as well, and you would get the exact same answer. Okay, so I got 2 plus 2 is 4, positive 3 plus negative 3 is 0, so it's gone. Negative 5 plus negative 11 is negative 16. Going to divide by the coefficient in front of y, gives me x equals negative 4. Pop that over here. I'm going to pick the easiest equation. Oh, actually, I picked the second equation this time. And I think I did that because I picked the first equation this time. So just so you can see, it doesn't matter which equation you pick. You'll end up with the same answer. Pop that 4 in. Be careful, because while I was doing one of these, I ended up popping my variable into the wrong space. You'll end up with a weird answer. All right, so just be very careful that you're putting x's in x's and y's in y's. Okay, so 2 times negative 4 gives me negative 8. I've got minus 3y, so I'm going to subtract or add 8 to both sides. Divide by the coefficient in front of y. That gives me 1. I'm going to make sure I put my x in the x space and my y in the y space. So pretty easy. All right. Normally we would need a therefore statement. For the most part, you just need a therefore statement if you have a word problem. And look how conveniently I have a word problem prepared. All right. So a caterer is making cookie trays for an upcoming holiday parties. This morning, she made 3 small trays and 4 large trays, which contain a total of 201 cookies. In the afternoon, she made 3 small trays and 2 large trays, which contain a total of 123 cookies. How many cookies do the different size trays contain? So, first step, let statement. So let S equal the small trays, let L equal the large trays. I don't care what variables you use, whatever makes you happy. So 3 smalls plus 4 larges equals 201 cookies, and 3 smalls plus 2 larges equals 123 cookies. Second step, create your equation. Third step, decide how to eliminate a variable. So in this case, my 3's are the same. I'll subtract them. Easy. 3 minus 3 gives me nothing. 4 minus 2 gives me 2. 201 minus 123 gives me 78. Divide by the coefficient in front of y, and you end up with my large trays hold 39 cookies. That's a lot of cookies. Right, I'm going to pop it into whichever equation I want. I picked the bottom one because the numbers are smaller, and I like being able to do things in my head. So I pop in that 39, make sure it's in the correct space. And then here we're going to subtract 78 from both sides, gives me 45. And divided by 3 gives me 15. So my point of intersection is small, large. I did it in this order because technically you don't have an x and you don't have a y, right? So does it matter which spot? I like whatever variable I set first to be the first, whatever variable I set second to be the second. So that's what I did, 15, 39. And then for full communication marks, therefore, there are 15 in a small tray and 39 in a large tray. Okay? Doesn't have to be complicated. Flip it over. So this one's cool. So if I have equations that don't line up at all, what I can actually do is change one equation so that it will match something in the first equation. So in this case, if I take this entire equation and I multiply it by 2, it will be the exact same equation. The numbers will just be a little bit higher. It's like an equivalent fraction. So if I have 2 times 2, give me 4x, y times 2 gives me 2y, and 10 times 2 gives me 20. So now if I stack them, uh-oh, if I subtract them, I'm going to eliminate both of my variables. So what's happened here? What do I even do with that? Well, let's take a look at it a different way. So if I rearrange this into y equals mx plus b form, and this isn't something that you would normally do to answer this question, I'm just showing you why this is, follow with me here. Okay, so if I rearrange this into y equals mx plus b form, so I move this 4x over here, I divide by the coefficient in front of y, I end up with y equals negative 2x plus 7 over 2. If I do the same thing with the other equation, I end up with y equals negative 2x plus 10. So if I were to graph these two, I would end up with the exact same line, and it would hit the y line at two different points. One would be at 10, and one would be at 7 over 2, or 3.5, which means those lines are parallel. So they're never going to cross. So I'll have the same slope, different y-intercept means it's no solution. The lines are parallel and will never cross. So if you end up with something like this where both of your variables disappear, that's what's happened, is you've ended up with, if you were to graph these two lines, they're the same line, different y-intercept means they're parallel. So that's cool. And here is a final example. What happens if nothing on either side lines up in any kind of way? I can't multiply 5 by anything nice to give me 6. I can't multiply 8 by anything nice to give me 5. Do I use decimals? Absolutely not. Don't do that. That's a headache in itself. So what I want to do then is look at 5 and 6, or look at 5 and 8. You could have done this 5 and 8 way, and decide what's the closest number these two can get together and agree on. And I've decided that number's 30. So if I multiply this whole thing by 5, and I multiply this whole thing by 6, that will give me 30 and 30. All right, same process as before. And then if I subtract them, I end up with something I can work with. All right, and then I just sub this 3 back in, same as we've been doing it before. We end up with 8. So my point of intersection is 8, 3. So long story short, as long as you multiply each of the pieces by whatever the number is, you can do that. It's like an equivalent fraction, okay? And you can multiply each of these lines by different numbers to make sure that they line up at some point. Very important piece of information. Don't forget this. All right, so if you would like to try number 4 before taking it up, now would be a good idea to pause the video and come back. Otherwise, I'm going to move on. If you're still feeling confused, then it might be a good idea to just watch me do this one. Okay, so a woman owns 21 pets. Each of her pets is either a cat or a bird. Meow. If the pets have a total of 76 legs, that's a lot of legs, and assuming that none of the bird's legs are protruding from any of the cat's jaws, how many cats and how many birds does the woman own? So, first thing we're going to do, let statements. Let C represent the number of cats, let B represent the number of birds, and I can hear you questioning me right now, Miss Bailey, do we actually have to write a let statement? Yes, do it. And it may not be very important now, but later when we have, by later I mean like grade 12 university level, when you have really complicated equations with multiple variables, this will help you write your therefore statement. It is a beautiful thing. Always write this down. Okay, then we're going to create our two equations. So I've got cats plus birds equals 21 because we have 21 pets. And I have 4 legs on a cat plus 2 legs on a bird equals 76 legs. And then I have to figure out how to make these two similar to each other. I chose to make the B's similar. So in this case, this one has to be multiplied by 2. So whoop, here we go. And then I stacked them. I subtracted them so that would get me the B's to 0. Then I divided by the coefficient in front of C, and that gave me C equals 17. So now I have 17 cats. Then I'm going to choose the simplest equation. And notice I used the original equation. I don't use the new one I made. And that's just a good idea. If you made any kind of mistake in here, this will help straighten it out, hopefully. And then hopefully you can figure out that you've made a mistake in here when you get to the end and you have a weird answer. But if not, at least then you've only got that mistake in one place. Okay, So I've got cats plus birds equals 21. If I have 17 cats, then I have 4 birds. So my point of intersection between these two lines is 17 cats and 4 birds. Notice I did cats first, then birds, so I did cats first, then birds. And therefore, she has 17 cats and 4 birds. So take a look at your homework, get that done, and I will see you tomorrow. Take care.